Okay, this is like 4B. This is the second part of the fourth review. I wanted a chance to put these up so you didn't have to watch me write. We're going to balance these, talk a little bit about the reactions, and go through the stuff after them. Again, the answers to the reactions are attached to this post. So let's balance. Cobalt looks good. Of course, cobalt looks good. He's my fish. We have to balance fluorine, though. I have 2 on this side, 3 on this side. It looks like I would need 3 of the 2. 3 times 2 is 6. And 2 here, 2 times 3 is 6. Need to balance the cobalt. So there we go. 2, 3, 2. On a multiple choice test, this would be, one of your answer choices would be 2, 3, 2. You pick out your coefficients. This one doesn't look too bad. 1 sulfate, 1 sulfate, 1 nitrate, 1 nitrate. It's the H and the K that's out of balance. 2 potassiums, 2 potassiums. Now 2 nitrates also. So that makes that very nice. There's a typo on your paper here. It's already balanced the way you had it, but since cadmium's +2, this 2 needs to be there. When I put that 2 there, it's going to balance easily with that. I don't think you could balance it before, or it was difficult because you did have 2 hydrogens. This one looks pretty easy also. Looks like my big problem here is just the oxygen thing. So that's fixed. 2 magnesiums, so 2 magnesiums, that's fixed. But now I have 4 chlorines on this side. And now I have 4 chlorines on that side. Remember on your test, when you have a blank, it's going to be 1. So your correct answer choice for this one would be 2, 2, 2, 1. Not 0, you have 1. 3 nitrates, 3 hydroxides. Good with the iron and the lithium, but 3 nitrates, so 3 nitrates. 3 hydroxides, 3 hydroxides. 3, 1, 3, 1. Good. Yuck, we're coming back to this one. Okay, it looks like I need to get my oxygens to add up here. Would need to get to 6 on this side, but check that out. 2 sodiums, 2 nitrogens, 6 oxygens. 2 sodiums, 2 nitrogens, 4 oxygens, plus 2 oxygens. Back to this combustion reaction. Combustion reactions always make CO2 and H2O. When you've got an even-numbered carbon in your hydrocarbon, there you go. This is going to be one of the messy ones where you either have to have a half or a 2 out in front. So if I do it without the 2, let's go 6 carbons. Okay, cool. 14 hydrogens here, so that'd make 7 there. Good so far. 6 times 2 gives me 12 oxygens plus 7 more, gives me 19. Yes. Half of 19 is what I'd have to have here because 2 times half of 19 gives me 19. Yuck. So that works. It's balanced. But if I don't like halves in these things, I can come out right off the bat and see just carbon and hydrogen and an even number and do that to make it go away. I now have 12 carbons. 28 hydrogens, that's a lot, but 14 times 2. So I've got 24 oxygens there, plus 14 more is 38, and half of 38 is 19, balanced with no halves. I don't care which one you do. I'm not going to give you one on the final with those crazy big numbers. You could have to balance one because some of the smaller ones balance up pretty nicely. But I'm not giving you the goofy ones. My goal is to make sure that you guys can do balancing, not necessarily goofy balancing. Check out these examples at the bottom, each of these reactions. Go back to the packet that I've given you the answers. Check them out. There's some nice looks at what I got, some practice classifying if you want. Give them a try if you want. Some of you did really well on those, but you've got your answers either way. Now down at the bottom, I have one stoichiometry problem on here. And I'm going to erase just a quick swipe here and put up those last couple. I'm glad I did this as 2 videos because there's no way I would have gotten all of that and all of this in one. Again, the answers to those reactions are attached. So I've got H2 plus I2 yields 2HI. If I have 16 moles of HI, I need to put that one on the bottom. My given goes on the bottom. My going to looks like moles of iodine. Looks like I've got 1 mole of iodine to every 2 moles of HI, meaning I need 8 moles of iodine to react to make 16 moles of HI. Good. So your data from your limiting reactant calculation. I did all the math, and I tell you what's going on. If you check that out, remember your limiting reactant's the one that runs out. So 10 grams of H2 made 1,280 grams of HI. I don't think so. 100 grams of I2 only made 101 grams of HI. Limiting reactant's going to be I2 because it made less of the product, meaning H2 is your excess reactant because it made more. You could never make that much. I ran out of the other one. How much HI is actually made? No math involved. 101 grams. Your lower amount is made. So I'm going to do the same reaction again. It's expected to make 250 grams of HI. That's real nice. But it only makes 185 grams of it. My percent yield. Little number divided by big number times 100. It's going to tell you what percent, basically what percent you got right. Like calculating a grade. And for this one, I got a 74% yield. Don't forget to multiply by 100 because it's your percent yield. There you go.